Welcome, Algebra. We're going to do a little lesson on permutations today. Permutations, mostly I guess this is just kind of an introductory lesson for you guys. You don't have to master this. In fact, in the chapter, I think it goes on to talk about combinations, and I don't want you to be overwhelmed with this. I want you to kind of get a taste of it, and then you'll probably learn more about it later. Let me introduce it with my favorite game, chess. Let's say you had a knight, you had a bishop, you had a rook, you had a pawn, and you had a queen. And your board, maybe it's all set up, and you're trying to make a choice of which person to move next. And if you think about it, how many different ways, or I guess how many different orders can you move these guys in? Let's say that these were our last four people, our last five people on the board, and we were going to move them one at a time, and we weren't going to repeat anybody. So think for a moment what that means. It means I could move the knight first, and then the bishop, rook. I could do it in this order. I could do it in the reverse order. I could do bishop first and then knight. And if you start trying to count this up, it gets very, very confusing. You can start to see pretty quickly there's a lot of different ways you could do this. Well, think about it. Let's try to get some order to our thinking here. How many choices do I have for my first piece to move? Well, if I just had five and I just moved one and then I had to move somebody else and I had to move a new person next time, how many choices I have for the first one just depends on how many pieces there are. And in this case, there's five. So I have five choices. I can pick the knight first, the bishop first, the rook, the pawn, or the queen. Does that make sense? So I have five choices for my first move. Once I take away one of them, doesn't matter who I pick first, once I take away one of them, I can't use that person again. So how many choices do I then have for my second move? Well, obviously that leaves four. And then if you keep going and you think about, well, what about my third move? How many choices do I have left? Well, I have three left. After I move these first two, I have three choices left for my third move. And my fourth move, there's only two choices left. And then my last move is whoever's left over. Does that make sense? Well, if I think about the different possibilities of doing this, what I really am trying to figure out is I'm multiplying these together. It's like probability. I have a 1 in 5 chance of picking somebody the first time. Then I have a 1 in 4, 3. So I'm going to multiply these. And when I do that, 5 times 4 times 3 times 2 times 1, we abbreviate that in math by doing this. 5 with an exclamation point, which I know looks a little bit like English class, or it looks like a very excited 5, but that means 5 factorial. So when you are thinking about choices of order, and when the order is important, that is called a permutation. And it's going to be, we're going to figure that out with what's called factorial. Okay? So depending on how many choices you have, that'll be the number factorial. If there was 10 choices, it would be 10 factorial. Let's just do 5 factorial real quick. 1 times 2 is 2, 2 times 3 is 6, 6 times 4 is 24, 5 times 24 is 120. You quickly get a large number of choices. Would you, at first glance, would you think there was 120 different ways that I could move those 5 pieces in a particular order? No. But again, there's a lot of combinations. I can move knight first, and then rook, bishop, pawn, queen. I can move knight first, then pawn, bishop, rook, queen. I can move knight first, then queen, pawn. And you can see it adds up very quickly. What about a situation where I didn't use all the pieces? So let's just pretend in my situation now that I have 5 pieces, but maybe there's only time, I only have time to move 3 three of the pieces. Okay? So I am only going to be able to choose 3 out of the 5. So the number of factorial possibilities that I have is, again, there's the total number of choices, which would be 5 factorial, but I'm only going to be able to move 3 of them. So I'm picking 3, and there will be how many left over? There will be 2 factorial left over. Does that make sense? If I write this out, it becomes a little simpler to solve. Rather than going 5 times 4 times 3 times 2 times 1 divided by 2 times 1, you're going to be able to simplify this a little bit because it's 5 times 4 times 3 times 2 times 1 over 2 times 1. And maybe you can see now that you can cancel this. That's going to cancel that. That's going to cancel that. And I'm really left up above with 5 times 4 times 3. And if you think about what this means is, remember, I'm moving one of the 5 pieces. I have 5 options for which ones to move it out of. Okay? I'm moving the second one of, I'm going to move, then I'll have 4 pieces left over. I have 4 pieces to choose from. And then for my third move, I have 3 choices left, and that's my third. I'm not really doing 2 and 1 because I'm not moving all 5 pieces. I'm only moving the top 3. So I'm left with 5 times 4 times 3. Okay? Or 5 factorial over 2 factorial. Okay, I hope that makes sense. Tomorrow you're going to come in, I'm going to give you a worksheet where we have lots of different practice of this. I think by the end of it you're going to feel real confident because it is a new concept. I don't need to go into as much detail as the book does, but hopefully this gets you started. Okay? All right, see you tomorrow.